Thunderstorms can be classified in several different ways. For example, by how long they last or how they look on radar. Another way to organize them is based on where vertically in the atmosphere the rising air that produces the thunderstorms originates. Turns out that two flavors of that classification method were on display in Pennsylvania this past Saturday. Now here's the weather map at 4 p.m. Saturday, focusing on Pennsylvania. I know it's a little busy with lots of numbers and symbols, but the key features to note are a warm front bisecting Pennsylvania from north to south and a cold front farther west that stretches from Lake Huron to Indiana. Now at this time, to the east of the warm front in eastern Pennsylvania, most temperatures were in the chilly 40s, even low 40s in the extreme northeastern part of the state. Meanwhile, in western Pennsylvania, on the other side of the warm front, temperatures were mainly in the milder upper 50s and low 60s. Yet the first lightning strikes detected in Pennsylvania on Saturday were in the northeast, particularly in Wyoming and Susquehanna counties, where surface temperatures were in the 40s. Now, those thunderstorms that formed with relatively chilly air down near the ground are an example of what meteorologists call elevated thunderstorms or elevated convection. In this case, the surface temperature was in the low 40s, but 5,000 feet up the air was warmer, in the upper 40s. Warmer air sitting over colder air produces a stable layer, which is not conducive to thunderstorms. So why did some form? Well, if we go higher in the atmosphere, the temperature dropped off markedly to the freezing mark, 10,000 feet up. Such a rapid vertical decrease in temperature creates what we call conditionally unstable layer, which means as long as that layer of air is sufficiently moist, you can get rapidly rising air, and that's what happened. In essence, the warm air that fueled those thunderstorms did not rise from the chilly surface, but instead originated about 5,000 feet up. In other words, it was elevated. Many of you likely remember Lee Grency, who used to be on Weather World. Lee liked to call this situation instability with a jacket on. Okay, so 3 hours later at 7 p.m. Saturday, the cold front was approaching northwestern Pennsylvania. Temperatures ahead of that front in the western part of the state were still mostly in the 60s. As for lightning, the thunderstorms in northeastern Pennsylvania were long gone, but strikes were detected between 7 and 8 p.m. in 10 counties in the western part of the state. And here's what temperatures looked like there in the lower atmosphere. In contrast to the earlier thunderstorms in northeastern Pennsylvania, it was relatively warm at the surface, mid-60s, with a pretty fast temperature decrease with height. Here, that bottom layer was not stable, but rather conditionally unstable, as was the layer above it. Now, with this configuration, the rising warm air that created the thunderstorms originated near the ground. So we call these surface-based thunderstorms or surface-based convection. This is more typical when you think about how thunderstorms develop. November thunderstorms are not unheard of in Pennsylvania, but in State College, for example, over the last 45 Novembers, I could only find about 45 days when thunder was reported, or about 1 November day per year on average. Stay tuned. We'll be back in a moment with more.